All right. Thank you for coming. My name is Mateusz Pusz, but it's easier to call me Matt. I'm a C++ trainer and a consultant also. I agree with most of the things, or all of the things you said, but well, I'm doing mostly C++ consulting for the code bases, not for products. So how to improve your code. So I have a bit different scope on things, but yes, this is challenging and also really interesting work. But mostly I'm doing C++ training, so in case you would like to have something in your companies, you know how to reach me. Today we are going to talk about the project that I spent at least 7 years of my life recently doing that. I got the inspiration for starting this initially when I was doing gliding, competitive gliding over the Alps and other high mountains. And when you're in a glider is basically a plane without the engine. On one thing, nothing can break, right? Because the engine is the thing that most often breaks. But on the other hand, you can only try to land once. And if you are wrong in your calculations, then you are stuck. And actually I was working on the software. I will show you parts of the software later on. But I was working on the software that was tactical flight computer that was providing me some guidance as a pilot. Where should I go, or where I will end up in like 10 minutes from now, assuming the weather conditions will not change. And this did many different calculations, and this is where I started to be scared when I saw into the source code. As a consultant, I've seen source codes of different projects, not only open source projects, but also closed source projects in different areas, automotive, in the plane industry and other places as well. And I was really scared to see that it's not much better than the one that I've seen in open source. And this is why I started to work on this library to improve what we do. If you will think about the old movies you've seen, like in 90s with maybe Arnold Schwarzenegger, whatever, they were getting into the car, and there was no driver, and it was taking this person to some other place remotely, right, autonomously. It was set in some really distant future, like 2000, 20, 100 years, whatever. But it's now. It's much faster than actually we imagined 20 years ago, right? Autonomous cars start to drive on our roads right now. And we depend with our lives and with our health on those, right? You want to go to sleep or you want to work while the car is driving you to a direction. And you want to be safe in this car. And it's not only about the cars, because there are other also things like surgical robots or smart healthcare devices that basically do everything for you. Like, for example, a surgeon may do it from the other part of, may do a surgery from another part of the world remotely. And well, if the needle will move not centimeter but an inch by the input from the surgeon, it will be a disaster, right? And in all those cases, this library is about to help a lot. We talked a lot about safety in our industry. It's a major concern lately. We think about different ways of improving the safety in our projects, in our programming language. We want to provide maybe better low-level fundamental types that will have, for example, defined behavior on overflow, for example, right? Or we want to update code language rules. Like, for example, there should be no implicit conversions from the floating point numbers to integral numbers, and vice versa, right? And also we want to provide safer libraries in order to provide some safer abstractions to our projects. And this is one of the examples here, talking about quantities and units case. In this case, we are in a really hard situation, because right now more and more projects, more and more engineers are expected to write life-critical, safety-critical, or basically mission-critical software on an everyday basis. Because right now everything starts to be autonomous, right? Everywhere we talk about cars, about things that do things for people. And more of us basically needs the experience in order to write such a software, but it's quite hard to come by. It's even not about the training, because training, of course, will help, because training helps a lot in making your skills better, but units is inherently tough subject by itself, even aside of programming. We made plenty of mistakes in different, totally unrelated to programming things, where we tried to communicate units or quantities, and we failed. I had a long list in my paper. Unfortunately, I don't have time to list all of them. I will mention a few only during this talk, where basically we failed with communicating units between different people. Also, plenty of software using physical units is written by non-programmers, just by engineers that are using C++ for their daily work as a tool. They are not C++ experts. They are not able to understand really hard C++ template compiler errors, or they are not able to understand basically or fix those errors or write the templates by themselves. In this case, we also want to provide really nice to understand interfaces and really nice to understand error messages, because this is really important to do so. If you ever used libraries like boost units, for example, and you've seen this huge error message, probably it's really discouraging for everyone to continue working with such libraries. When you talk about affected industries, we typically think about aerospace, autonomous cars, embedded industries. Those are the obvious choices here, but actually the scope is much broader. We have maritime, military, astronomy, 3D design, robotics, even audio. There's plenty of use cases for such a library. Of course, all of the universities, scientific institutions, even GUI frameworks, or even finance with HFT is our customer for this library. In my paper, you will find plenty of examples where actually we failed in communicating units, but I decided to put one of this in the list here and a bit more later on, because this is a local thing. Right? Even today I was in the museum before this, so I'm prepared. I have even some photos from my trip today. Yeah, you know about Vasa, right? But what didn't they tell you in the museum, and actually it's written in some reports and in Wikipedia, is that one of the reasons for it to fail is that it had asymmetrical hull. While it was built by two different crews. The port side and the starboard side was built by different teams, and they actually turned out that they didn't communicate what kind of ruler they are using. One team was using rulers that were calibrated in Swedish feet, which is 12 inches, and the one was using Amsterdam feet, which was 11 inches. And this basically ended up with one side of the hull being thicker than the other one. And that's why it collapsed to this direction, not the other one. Of course, the fact that it was collapsing, it is a totally different thing, right? Not enough stones and bad shape of the boat, and too many decks and too many cannons and everything, right? But because of it, there was only one direction, it can actually fail. And this was one of the issues that we failed to communicate units a long time before programming was invented. But let's see some programming issues. This is part of the software that I was contributing to. And this is when I started to work on my physical units library, because I wanted to improve the world. It looks scary, right? Consider how the use case for this looks like. How many numbers you see in the call side of this function, and how easy it is to basically reorder arguments. And everything is a double or a pointer to double, right? Also, there's plenty of magic numbers. I don't dare changing this line. I don't know what it does. I may have some rough understanding of a few of those, like this looks like Kelvin conversion, but the rest, I don't know. Right? And how we deal with things that we have magic numbers? We typically write conversion macros. And when actually I started to look for the same macro in the same project, I found different definitions in the same repository in different headers. also, this is one header file, and those functions are one after another in this header file. Do you see something strange?
Not strange, quite usual, but all of them are double.
Right, lack of consistency. Did you see one or two issues? Who saw two issues?
Sometimes it's lat long, sometimes it's long lat.
Yes, so this is the one issue. The second thing?
Output arguments and like actual return arguments.
Yeah, but instead of lat long, there's also one more. Distance, bearing distance. They are consistently inconsistent in this header file. And this makes it really hard to work with, especially if there are doubles, right? If there were strong types, the things will just not compile. If there are doubles, it's so easy to make a mistake. Yeah, this is me like 8 years ago, right? Or maybe a bit more, because actually it was 12 years ago. I started to work on and look for alternatives, but it was really hard to do anything at this point. I did like 2 or 3 prototypes, but they were like crappy. Only starting from, I think, 2017, when C++ technical specification for concepts were specified and implemented by GCC. GCC was the only compiler that implemented the technical specification. I started to work on my new interfaces using concepts for this library. So, important stuff, right? Compile time safety. We have to be able to prove as much as we can at compile time. This is really good in C++. I have other talks when I compare this to like things like Python or Java, where basically, well, C++ does much better. Performance, another place that it does much better than Python and Java. And by performance, I don't mean only runtime performance, but I also mean no space size overhead, right? It should be as big as int or as big as double and not bigger. For us it is obvious, but if you look to Python or Java, it takes like 100 more space than the primitive type. Great user experience. As I said, it has to be easy to use, easy to understand, and easy to fix errors if something happens. Because the biggest actually reason for this to exist on the market is to generate errors. If it doesn't generate errors, if you are not doing any mistakes, you don't need it. Why to pay for compile times, right? If you're not doing mistakes, then this library is useless. You just write your magic numbers, you just write everything as it should be, and it works. The most important thing of this library is to generate errors every single day, multiple times for the user. And the user has to be able to understand what it does. Scope. We have to be able to express any unit's magnitude, huge or really small ones, or floating points, like from, for example, degree to radian. System of quantities has to be supported, system of units, the affine space abstractions, text formatting. Different people have different requirements here. And also we have things like scalar, vector, tensor quantities. And also there are some people saying we want to be able to express natural unit systems, which is quite tricky if you don't know the subjects. And then basically it means that you can, for example, express the distance in time, assuming that c, speed of light constant, is equals 1. Right? If you assume that the speed of light is 1, you can measure how much or how far is the wall there, assuming the time the light travels to the wall. And easy to extend, because we want to implement our own stuff inside. This is a bit sad, because my library uses C++20 as minimum support. We have 2024. GCC, Clang, they're fine from 12 and 16. Apple Clang 15. MSVC still doesn't support the library, still doesn't support C++20 properly. I'm basically well, maybe not working because it's said too much. I'm escalating the issues to MSVC developers and managers for at least 2 years right now. And basically they say, well, we work on right now security in our projects. We don't care about this too much. And hopefully it will improve, because right now we cannot compile this with MSVC. If you're on MSVC, I'm really sorry, but it's not my fault. they are just having too many issues like lexing even or parsing problems, not saying about C++ things inside. And this is only for C++20 mode. Minimum support, I mean C++20. And then there are some extensions, right? Stud format, this is also 20 modules, and those are C++23 extensions. Static context variables in context functions and explicit this parameter from C++23 are also supported by GCC and Clang right now. I still have some issues with GCC 14 for modules. It's not only my problems, also other speakers and other committee members working with modules with GCC, they say that basically GCC is broken, doesn't work correctly. Even though it was meant to be the best library, the best compiler when it's released in April this year to support modules. But it doesn't work. It was not tested properly. You can find my library on GitHub, Conan, and Compiler Explorer. So it's easy to start with and play with it. If you want to look into this standardization, I was asked a few years ago to provide a discovery paper saying how the background, basically the community, how the project, how the this thing like physical unit libraries are being implemented all around C++. So this was like a discovery paper. But this year I came with more papers. This one and this one is the main one, being right now in standardization. There's plenty of interest in this one, and hopefully it will become a part of the standard. There's also some associated papers where we talk about the design of library of number concepts. Basic fixed string will go there. If you want fixed string, it will be in C++26 probably. And a few more papers. There is a lot of interest in the committee. We spent plenty of hours already on this one. Hopefully, we'll not lose track and continue in standardization. Because I said in the beginning, if you don't want it, I can go away and this is fine. But don't ask me to work on this for hundreds of hours and they say we don't want it. Right? But it happens already. I don't know if you've heard about the graphical proposal, but it was something like this one. Some guys worked for 4 years and were asked always do more work, do more work, do more work, and they said we don't want to lose our time on this. And it was not fine. So we learned our lesson in the committee as well, and we said we don't want to repeat our mistakes. We want to say to the authors right away that if something is not going to happen, the authors should stop working on this. At least we don't encourage author to work, because we cannot forbid author to work on this one if he really desires. But we don't discourage no one to do more work if we are not interested in this one. For now, there is interest. All right. So let's see how we can solve some stuff with library. This is without the library, right? If you don't have library and you're using doubles, I hope that you are using those postfixes. Those postfixes that always say exactly what unit is being in use right now in specific variable, right? Meters, miles per hour, and so on. Well, meters or miles, right? It's hard to understand. And you have some result. Right? Prefixes or postfixes are really important here. Also, you have those magic numbers for conversion factors, which are not fine, as I said, because we typically use macros. But we don't like macros in C++, so plenty of projects instead of macros started to be modern. They use context variables. And with this, they are modern, and they basically use multipliers as context, which is maybe a bit better. And this is how you use it with the my library or similar libraries. You specify the distance. This is meter. This is mile per hour. You don't need any intermediate variables anymore. It just does the conversion by yourself. If you want to have it in seconds, it will just do thing for you. Right? And you don't have to specify anything in the names that you are using those units, because this is described in the type already. I don't spell this in the type because this is class type argument deduction stuff, but it is there. If you would look this in the compiler error message, the type will spell that this is meters, this is mile per hour. And then if you want to print it, basically it prints the same question.
Is it supported in IDs like IntelliSense or not? Like you want to see what will be the type of the distance in the where you use it.
Yes, it is supported, but also it is tough with IDEs because IDEs typically are on Clang and typically on Clang -2 release because it takes time for Clang D to catch up and then for the IDE to use this Clang D, which means that in most cases, in many IDEs, we still have like red squiggles everywhere saying we don't understand the syntax of this thing because Clang started to support basically this properly like 1 or 2 releases before. Even though C++20, right? But hopefully the Clang D will improve and IDEs will import also Clang D from the latest revisions and this will be better. But yes, of course, you can always check the type of the specific things. I think even right now. But for other things, you would say like plenty of squiggles, unfortunately. Right, so the library knows all the convention factors. You don't have to write any of those or any of those. The library knows everything by themselves. All right, so now I made a mistake here, right? I did, instead of division, I did multiplication. Here I get some result. And here I get an error message. An error message that is already quite nice, but if I will strip some additional things that Clang tries to do here, I don't know what it does, what it means. I actually submitted some bugs on this to improve printing. And this is how it should look. Then it's quite easy to understand, right? No magic member function for call to in, constraints not satisfied, because unit compatible with second is related to false. And you say if here see exactly what happened, that we have quantity of power length 2 and per time evaluated to false, because this is not per because we multiply stuff, which is written here. So this is quite nice, and you can see everything from this short error message. This is entire error message that is printed, nothing more is on the compiler error message in this case. All right, so now let's see about interfaces. Right, in interfaces, again, you have doubles. In arguments, you provide the postfixes, but also the function name here also needs a postfix saying what will be the result of this function, that the result time to go in seconds, right? You cannot put identifier here, so you have to put it in the function name. Here you don't have to do it, you just say quantity in meters, quantity in kilometers per hour, and quantity in seconds. This thing is amazing that we can type it right now in C++20. This was impossible before C++20 to do things like this, to do arithmetics in template parameters list. And this is why C++20 is required for this library, because this syntax is awesome. And then you do some calculations. Distance kilometers, I convert it to meters, and do speed kilometer per hours, and print it. I did here the same. I just used 2 variables, so I don't need that, but I provided those 2 to have different names, because I will show you this in the next slide, why I use it. And it provides exactly the same answer, of course. If I will make a mistake here, and I will put a kilometer instead of meter, this was meter, right? Then this provides me a totally different answer. Instead of 400, I have 0.4, because 1,000 difference, right? And if I do the same mistake here, I have still a proper answer, because the library will do implicit conversion from kilometers to meters, because this is considered always a safe conversion. Other way around is truncating, so it's not safe. I will talk about this a bit later, but this way it is fine, library will work. In other way, you will get a compile time error, not an incorrect result. Right? Yes? Yes, but I cannot do anything about it. This is the representation type we are using, right? That's why I said in the beginning we also want to have better fundamental types in our library that are safer. This library takes anything that you put to it as a representation type. If you want to be safe for overflows or other fundamental type specific stuff, you have to provide this type instead of 10, write something like my safe int 10, right? And then the library will use your type instead of this one. So if you want to prevent numerical type issues, you have to use save type by yourself, and then everything works fine.
I have a question.
Yes?
Excuse me for my ignorance, but like, how does the compiler treat the kilometers per hour template parameter? Does it consider that as a type, or like how is the division treated in this case?
Yeah. Well, division is quite tricky if I have to be exact, because some users actually wanted to have making this working like this. So what happens here? I have 90. Multiply it by kilometer, so I have a quantity of length. Then I divide quantity of length by hour, which means that I create a quantity of speed, which sucks if you think about this way. That's why initially I required people to put a parenthesis around it. So I first construct a unit of quantity of kilometers per hour and then multiply it by a number. But then people complain that this syntax doesn't compile. They didn't know that they have to put parentheses. So this, what it does, basically, it creates 90 with a tag kilometer and then divides and does 90 with tag kilometer per hour. It's put in the type. The object itself just stores the value 90. The rest is in the type. Yes?
So what is the underlying type? Is there any influence that you can have? Say I want to, I mean in some cases I could be fine with an int and have better precision for a lot of conversions. Right now I don't see whether it's int, double or float anywhere.
In this type it is double, right? Because it has dot.
It's because of basically what you put before will determine.
If you're using CTAT, class parameter deduction, then you will always get what you provide to it.
Okay, I see.
If you are not using CTAT, so you specify something, then default is double, but you can of course provide your own. Yes?
I would assume that if distance and speed would have had different base types, like double and int, for example, it would compile them, right?
Yeah, it will. If distance and speed will have different types, like int and double, yes, it will just work fine. And this will have int, this will have double, and then if you will do some calculation, like here, you will get the common type, which is double, as a result.
How would it handle two integers? Will it?
It sucks. Well, basically that's what integers do, right? If you will take like 2 and divide by 8, you get 0, right? And this is what it does, right? It doesn't do anything else. If you do 2 divided by 8, you know what the result is, right? And the same goes here. I'm not doing any conversion of the input values. That's why actually some of the libraries, like AU library or a unit library, basically forbid doing any arithmetic on integer types. They just said it's not supported to make it less confusing. But on the other hand, embedded industry is really sad because of it.
Question for understanding: the units, are they types? Are they objects?
Well, if you spell this here or here, this is an object of a tag type. So each unit has its own type. So they are both types and objects, but user always plays with objects, but observes types in the compile time error messages. We'll have soon another compile time error message, then I will point it exactly how it looks on the compiler error side and the type side. But each unit has a unique type, and this unique type has an instance like this, for example. Yes, question?
You said by default underlying type will be double. What kind of default?
Template parameter default is equals default for representation type. So, if I make a mistake, and I will provide arguments in an incorrect order. Remember those interfaces I showed you, how easy it was to make mistake on doubles, right? Again, I have some result, right? As expected. Here I have a compile time error. Could not convert speed from quantity of derived unit kilometer per hour. This is what you get. This is what you get from that. This is kilometer per hour. And this is how the type looks. It's that long. If you try to do this with boost units, this slide will not be enough to store in the first line in the same font. Yes?
What was the incentive to specify which unit
SI, right. Hour is officially not an SI unit, a second is, but hour not. But there is a list agreed by SI saying those are non-SI units accepted to work together with SI units. The specific list like of 8 or I think like 12 maybe units where actually there's hour and there's I think like degrees and other stuff on the list. And electron volt and maybe a few more.
But is it just convenience?
Actually, you could write SI here as well, because I have non-SI as a namespace when it's defined, but also then I include this to SI. So I could write SI hour for users that are not aware of those issues. I don't want the users to struggle. As SI allows to use hour, this one is included also in SI namespace, right? And this is the same thing. This is just the using declaration. But I defined it non-SI to be pure, saying that this is SI and this is not set of non-SI stuff that are allowed to work with SI.
Do you cover all SI units?
Yes, of course.
All right.
There are not many. Actually, much harder is the other thing I will show you later.
I mean, it's a pretty far-fetched question. How do you deal with different uses? Because sometimes people might represent units in different ways. Will it automatically pretty print the final unit? Say, I mean, my physics lessons is long ago, but a lot of units are defined in terms of other units. Like, I don't know, like an ampere, for example, is like coulomb per second, like the electrical whatever of an electron per second. So how do you deal with that?
I print whatever is in the type, right? If I write kilometer per hour, I write kilometer per hour. If a user will for example, create their own unit like kph, I will not type kph here, but the user will be able to convert this to kph and then kph will be printed.
Yeah. Yeah,
Right? So I print exactly what the user says. I will not compose a unit by some magic means saying this is ampere, right? From some composites. I'm not going to compose those because this is a problem. One of the problems I've noticed was that my previous version 1 was actually doing this. When I saw 1 per second, I said that it's hertz. And the user always seen hertz. But then people started to complain, well, I want to print becquerel instead of hertz. Or I want to actually say I'm counting cars on my highway, and I say those are 10 cars in second, not in hertz, right? Because 1 per second by itself is a unit, right? I don't know what is the use case. I don't want to be too smart. I was too smart in version 1, and this was not the best thing to do. Right? So I'm printing exactly what you have. And you can write that I have like joule, and I have kilometers, meters, and kilograms, whatever, instead of joule and any other version you want to have, right? How you want to print it? You just convert this to a unit of your choice, and then print it, and this will be printed as you want.
Okay, so then you can probably convert like, and then it's a no-op conversion.
Yeah, it's just compile-time conversion of a type. It doesn't do any runtime stuff, assuming that you are not changing the magnitude of the unit, right? Just different representation of the same unit.
Yes, like I don't know what a joule is, but yeah.
Sure. Yeah, really good questions. Thank you. All right. Again, mistake. Mistake, this is not speed anymore, right? Or sorry, time to go. It's not speed, example, time to go. Another wrong answer, and another nice error message saying could not convert from quantity of derived unit kilometer meter per non-SI hour. So I have kilometer meter here to basically expected output, right? So it says there's no per here, right? And kilometer meter didn't simplify. That's not kilometer per meter. And this is it. Because we multiply instead of divide, so the length units will not simplify here. And talking about the performance. This is how the assembly looks. This is how the assembly looks. It is the same assembly, it's just the order of lines different because I'm doing the operations in a different order. No overhead. The same runtime performance, the same size, because this is size of double, so we don't pay for it at the runtime at all. But this is fine when you want to always provide the unit of an argument, meter, kilometer per hour. But so there are cases where actually this is not correct. For example, we have a function like average speed, and you want to provide average speed in the unit provided by the user. If the user provided kilometers per hour, you want to provide a speed in kilometers per hour. In miles per hour or miles per second, this should be the return. You don't want to pay for the conversion on the input and then for another conversion on the output by the user to a unit of choice. So those are not the best interfaces for such use cases. That's where we go to generic programming. And with C++20, we can write templates this way, right? If you're not aware, this is a template. Right? And I write quantity of length, quantity of speed, quantity of time. And with this, I can specify that I have distance to turn, 400 feet, car speed, 40 miles per hour, time to go, and turn right after 6.8 seconds. I can provide different units. Distance to Garda Lake from my home, 1,500 kilometers. Average speed expected on the highways, and I get the result. Or I can do half marathon race in kilometers, provide the pace, 4 meters, 4 seconds, 40 seconds per kilometer, time to go, and I will get some result. What will be the result of that? Who knows? Who sees? What's the problem? With double, it will compile. The question is, what is pace? Cause unsatisfied. This pace is not a quantity of speed, because pace is actually the inversion of speed, right? If you're using your Garmin watches to track your activities, you know the pace is a strange unit and a strange value, right? And this will tell you that it doesn't work. So you have to do one per pace, and then it works, and everything is fine. Or you can use affine space abstractions. In this case, we're using not quantities, but quantity points, saying this is cloud base, 1,800 meters. My glider is at 1,200 meters. The strength of the thermal is 4 meters per second, so I'm going like a really fast elevator upwards. And it says that I should exit the thermal in 144 seconds, otherwise I will be sucked by the cloud, and they will not see anything. Right? And this is quantity points, so affine spaces. When you subtract them, you just take a quantity as a result. This is the same as duration and time point, right? Or pointers and pointer diff, right? In our programming language. All right, so those were some examples of how this looks like, and let's talk about the safety features in isolation. Safe unit conversions. I have 5 kilometers. I can say in meters, and I get meters here. It is fine to always convert this time, and the compiler knows all of the magnitudes, all of the conversion factors at compile time, and it does all of the thing for us. We don't have to spell any magic numbers here. Right? In stud chrono duration, the magnitude is represented with stud ratio. And this is not enough for general purpose physical units library. It's actually even not enough for the chrono, because it doesn't support, I think right now 6 or 8 of the SI prefixes. Because I think it's right now 8, because it was extended in November last year, I think. The list of official SI prefixes. Because stud ratio is composed from int max. With int max, you can do just as much. You cannot express huge and really small factors. So for bottom and for higher and for bottom of the prefixes from the list of SI are not supported by stud ratio. And then we cannot express things like electron volt or Dalton. Or also we cannot do conversions from radian to degree with stud ratio, because this requires pi on the way. Right? How to express pi with stud ratio. So we have to do something different. We are using different things. I'm having something called magnitude. I'm using mag power of 10 to the power 3. And this is kilo. This is prefixed unit. And then I have kilo as a helper variable template, and I can write things like you've seen kilometer before. So I have meter, second, this is named unit, you specify the symbol, specify the kind of quantity associated with this unit. This is length, this is time. And this is how you specify basically units. And then you can specify also symbols. As symbols are really short identifiers, they are in separate namespace that you have to opt in by yourself because it may collide with your existing identifiers, right? And this is how you specify units, one line per one entity. So easy to do, no macros. If you know other language, other libraries, there's plenty of macros or plenty of lines you have to write for each definition. Here, just one line. And this also, again, thanks to C++20. And this is how we specify this non-SI minute hour. In this case, I'm using magnitude 60 times second, magnitude 60 times minute. And I have another symbols. Or in case of international units, yard, mile, I'm using mag ratio of this ratio, and then this times yard gives me a mile. So those are the things how you can provide different magnitudes for different units, and for each of those, one line per one definition and for each symbol. Next feature, preventing truncation. If you divide stuff incorrectly on integral types, you will truncate. And you want to prevent this as much as possible, right? All right, so we've seen this conversion in the other way around before. From kilometers to meters, I said it was fine, but from meters to kilometers, it is truncating if it's an integral value. This is obvious. In this case, it doesn't compile. Either if you're doing in, or if you want to do basic initialization from meters to kilometers, right? Kilometer. So it's always truncating, we don't allow it. Floating point types is considered value preserving. That's a lie, but we don't have a better way to spell it in C++20 as of now. We hope to have better type traits in the future, saying like this is value preserving conversion between types, but we don't have those as of now, so we are basically copying what Chrono does to be consistent, and Chrono assumes that floating point numbers are basically value preserving. And this is what we do as well. So in this case, if I do double, I can do this conversion with no issues. Or I can say in double on an integer, and this will work fine, or assign to this one without any parameter. As I said, double is my default, right? So this is variable in a double, so I can convert it, and this should work fine. Here I had int, right? Explicitly stated. Here I don't specify. I could specify double or nothing. It is a floating point value. Yes?
I have a question. You tell about physical values, but how about byte, kilobyte, and kilobyte?
You remember Mac power? It has 10 and 3, for example. In this case, I have 2 and 3, and it works. Right? I had Mac power as a magnitude for the unit. I had 10 and then the power, so I can, instead of 10, I can use 2, and then I can express any IT prefix as well. It just works. And again, everything in a type, and value is just what you spell. So it's really fast to do all of the calculations in this domain. Truncated conversions can be explicitly forced. If you want to do this truncation, then you just write force in or value cast to kilometer, and then it works. This is controversial name. I'm looking for a better one, but I cannot find a better one. Because when I tell it for the very first time, probably you didn't think that's a problem. Now probably you start to consider that in English, saying force in kilometers probably doesn't sound right. We thought about coerce or cast to or whatever, but we don't know the better name. Probably we'll have to find something, or we'll try at least in LEWG. LEWG likes refactoring and basically likes bike shading. This is what they do the best, and probably they they will find better name for it. Or at least they will really try to do it. Preventing truncation of data. When we have floating point and you convert to int, again, compile time error, right? This is obvious. And again, you can use value cast to int. This time I'm using the type here, not the unit. This was unit. Here is a type. And then it's explicitly forced by the user, but you see it in the code that truncation happens. All right. So this is the first part of the safety things that probably you expected, because this is what Chrono does, right? Nothing fancy, nothing interesting, maybe a bit different syntax, but this is what we've seen. I will show you the second part later on, but let's have some interrupt in the meantime to have some maybe fun story. Let's try to find out why Columbus thought that he reached India. He started here, from Tenerife. Actually, he started here, but he got to Tenerife, resupplied, and then went west. And was able to come back and say that there is a land. Columbus was doing a discovery for his trip. He met Abu al-Abbas Abbar in Muhammad ibn, and yeah, aka Alfraganus, who was a medieval Persian geographer. Columbus learned from him that he estimated the degree of latitude to span 56.67 miles. And he assumed that on equator, the longitude should be roughly equivalent to latitude. Right?
Because you have a sphere. He assumed it's perfect sphere.
Yeah, but this is not the biggest problem that he had. So let's see. This is my code, right? We have template, unit of length. We provide some mile. And you have estimated degree. Estimated degree with the name deg and meg ratio. This is this 56.67 miles, right? In Europe, at this point of time, we were using Roman foot. Roman foot actually was the length of the foot on the statue of Kossuth. It was 296 millimeters. And then we had Roman pace. Roman pace was the length of every other step of a legionary marching to the destination. I was supposed to stand here, sorry. For the camera. And then the Roman mile. The length of every other foot of the Roman legionaries hitting the ground 1,000 times. This was the system of units used in this time in Europe for length. So when we try to code it, foot Roman, 296 millimeters. Pace Roman, 5 of those, and 1,000 of those is a mile. But it turned out that Alfraganus was a Persian, basically person and this geographer, and he didn't use Roman mile because it would be too easy. He used Arabic mile when we actually communicated this to Columbus. And Arabic mile was, we roughly estimate right now that it was more than 2 kilometers of distance. And we know that right now, with all of the satellites we have and all of the knowledge we have, that this is the correct, actually, distance of a mile on the equator. So I create Columbus degree, Alfraganus degree, and equator degree as units. Write a simple function to print my error, right? Approximate exact absolute of subtraction and dividing by x, the exact value. And I print it. I have Roman mile in meter, Arabic mile in meter, and the error between Roman mile and Arabic mile. This is what Columbus assumed. This is what Alfraganus meant. He already made a 31% error in his estimations for the travel. And of course, he was too short, right? So it is optimistic. That's not that far. If you check equator length, actually in meters, it turns out that actual equator length is somewhere in between. So Columbus actually was quite lucky because the error dropped a bit to an actual size. But then, when he noted mile of 1 degree of equator, basically the length of it, he had to find out how many of those degrees is from Europe to Asia. And he used the truth, Bible. In Bible, it was stated in some versions of Bible, actually is the two Estradas, apocalyptic book in a Bible. This is stated, 6 parts are habitable, so there is land, and the 7th part is water. So the Bible says that only 1/7 of the earth is covered by water. And he said, well, this is really optimistic, let's use it in our preparations. So he assumed that there's only 68 degrees between Europe and Japan or India, whatever he wanted to reach at this point. If you know geography, it's much more than 68 degrees. This is the actual distance from Tenerife to Bahamas and from Tenerife to Japan. I'm using different units, so yeah, this is much longer. And I'm printing all of those. Columbus' distance was 3,000 nautical miles, the one that he assumed he will go. Actual distance was more than 3 times longer. He made a huge mistake of 70% in his calculations. It turns out that he was so lucky because the Tenerife-Bahamas distance is nearly what he calculated. If there was no land on the way, we'll never hear about Columbus anymore. And he was so happy to reach the land. So this was a lot of different accidents and fortune for Columbus, that actually he reached the land, he discovered America, because otherwise they will starve to death or basically will not have enough water on their trip, and we'll never hear about them anymore. Notice that this code was correct by construction. You could enjoy the story, you could just enjoy the logic of the things I was doing. You never had to track if the calculation is correct. Imagine doing all of those Roman miles, Arabic miles, actual miles, and all of the meters and other things that I used with doubles and conversion macros. There will be no fun story like this one if you had to verify all of those things by yourself on every slide to find out if there are no errors. You may think that writing your own library is easy. I will show you in the next slides that there are probably a bit more things that you may not think about while doing that, because things that we already discussed, as I said, may be obvious because this is what Chrono does already. This is Chrono, stud vector of Chrono milliseconds. I am place 42. I have 42 milliseconds in this vector. This is today. This is tomorrow. Code compiles and works. I don't want to say that the authors of Chrono did it bad, because this was awesome at the time it was standardized. Right? It was 14 years ago or 13 years ago. It was awesome. It is a great library, but we found some issues with this as well. This is one of them. Right? With my library, this will not compile. We are not allowed to create a quantity with just a number. You always have to spell a unit in initialization. This is the reason. Right? If I do this or this, I can use comma instead of multiplication. If you don't like multiplication, then you can use comma. In both cases, this is okay because this is a safe conversion if needed to second. Otherwise, we will have a compile time error, but unit is always there. Save quantity numerical value getters. The same goes if you have some legacy function like this one that takes the argument in seconds. If you have vector chrono duration, this takes seconds, I put seconds, I do count, looks correct. You just don't remember that actually this second is converted to microseconds, and then that's what you get with count. Of course, there is duration cast to prevent this error, but plenty of people don't remember about duration cast, especially if units match, or even this unit match, well, this unit match today. It may not match tomorrow. Right? This is the reason why we have numerical value in, and we have to specify a unit again, always, when we want to get the value, to provide additional safety. More. How do you like the interface like this one? I have a box, length in meters, width in meters, height in meters. Length meter, 3 arguments. And floor as an area in doubles. We said it's not fine, right? But if you take any other library on the market for physical units, this is what you get. Is it better? Length, 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 and maybe area here, maybe a bit safer, but still you spell something like this for the box. And actually I talked to guys from Boston Dynamics. You know, they are building this robot that is intended to put things in the warehouse. They did many of issues like this for this box. And we want to fix it, right? We don't want to end up with giraffe, Melman, laying all the time in the travel. So we introduce a new abstraction. Dimension is not enough to specify all properties of the quantity, so that's why we ended up with so-called quantity spec. And because more than one quantity may be defined for the same dimension. We have quantity of different kinds, frequency, modulation rate, activity. We have quantities of the same kind, length, width, altitude, distance, radius, wavelength, position vector, and many more for length. We have different characters, scalar, vector, tensor, or even some of the quantities are defined and non-negative. We can use all of this information to improve our type safety. And we need some type to store it, and we basically named it a quantity specification. Maybe it will be backshaded by the LWG, I don't know, but that stores all of the additional information. And this is what ISO 80000, International System of Quantities, says, that we have more lengths, and this is what 3 is specified by ISO standard, saying how those lengths compose with each other. It looks reasonable, but it's also a bit tricky, because length means any length. So if you're talking about box, typically you say length, width, and height, right? So you have height here separately, width separately here, but those are also lengths. So even this is somehow overloaded term in our daily life, what the length means, right? But there's no issue. I can create a new horizontal length by myself, easily saying this is quantity spec of length, to create a new branch here for horizontal length, right? And then I say horizontal area is a kind of area where I actually have to use width and horizontal length as composites to get this one. And then I can check that actually horizontal length is a length. Length is not every length is a horizontal length. Horizontal area is always some kind of area, but area is not always a horizontal area. So everything works as expected right away from this definition that you specified, right? And length by length is an area. Length by length is not a horizontal area because it may mean something else. But horizontal length times width is both area and horizontal area because this is what it does. From those two lines, this just works, thanks to those trees. And this is quite awesome. And this is nowhere in other libraries, in any other programming language. So with this library, you can write quantity of horizontal length, width, height, provide those here, and horizontal area as an outcome here. And then you can specify this in 3 different ways. You can either specify it this way or this way. Basically, they end up with the same type, but they are doing something different under the hood. I don't want to go into details because actually I should finish nearly already with my talk, or soon. And I have still plenty of slides. I will have to speed up or skip some of them. But also you may say, I don't care. I want to be unsafe. And this is up to you. If I say meter, I mean any length, right? And this is fine to specify this because someone may provide you really strongly typed library with the interfaces to be generic, but you don't care in this situation because you have like only one length in your system. And you don't care about length because maybe you care only about voltage, right? In this case, you may just say, I'm using units, and then this converts easily, and you don't have to be too strict. But if you care, you specify it, and then you have all of the safety with compiled error messages where needed. So those are called typed quantities. You specify this is horizontal length in meter, width in meter, and so on. And then there is a bit longer, because you see quantity of reference of ISQ height and meter. So reference is something that specifies a type of the quantity, and you say this is quantity of height and meter, and type int, right? So you wrap it in the reference type. But still, it's quite terse and easy to understand, at least I hope. And then, of course, everything works as expected. Another interesting thing. What should be the answer for this question? 1 Hertz plus 1 becquerel plus 1 bot. For Hertz is a unit of frequency, bot is a unit of activity, bot is a unit of modulation rate. All of them are quantities of dimension time minus 1. I ask different libraries, boost units. I cannot use bot because it's not supported, but it says it's 2 Hertz. I thought maybe this uses always left-hand side for the unit, so I tried the other one. No, it's also 2 Hertz. Nick Holzhaus library, really popular one, and great library for its time that was designed. Also compiles, but says maybe a bit better. This is just 2 seconds minus 1, so take some common stuff from those. But still allows this comparison to be done. So this is C++. I tried other languages, Pint. Pint supports bot. 3 Hertz. I tried the same trick, 3 becquerel. Talking about consistency of addition, right? And I asked Java. Well, don't laugh. This is where they live. This is how they do arithmetics on custom types. But actually, this is the only library that is correct. We have a compiled error saying those are different quantities. They should not be added together. And see how nice error messages, just 3 lines with the exact information what's wrong. Probably will never be able to provide such nice error messages in C++. So we may laugh from this ad, but this is awesome. So how we solve it? The answer comes again from the ISO standard. ISO standard specifies something called quantity kinds. And it says quantity may be grouped together in categories of quantities that are mutually comparable. Mutually comparable quantities are called quantities of the same kind. 2 or more quantities cannot be added or subtracted unless they belong to the same category, so they are basically of the same kind. Quantities of the same kind within a given system have the same quantity dimension, but quantities of the same dimension are not necessarily of the same kind. And this is exactly what we have here. And it says those are all quantities of time minus 1. The same dimension, totally different quantities. We don't want to mix those. I had to represent something that says, well, I'm the kind of, to specify the same as ISO says, so I created kind of modifier. It denotes a family of quantities, so basically if you put kind of length, you will say this thing represents anything from this tree of length that I shown you a few slides before. This is any length, right? So if I do get kind of width and get kind of height, this is exactly the same. If I check exactly get kind of width, it's actually kind of ISQ length. And such kind of is implicitly convertible to anything, like kind of length is also a width. Quantities of different kinds can be compared, added, or subtracted. You specified kinds. Here, you should see already this named unit. This is kind of time, so seconds is for every time, meter is for every length, and so on. Right? And you also can specify this for some derived units. I say this is radians to radian, hertz. Hertz is like inverse of second, kind of ISQ frequency, kind of ISQ activity, and so on. If I want to be strict, saying those are limited to specific quantities. And then if I write things like this in my library, I get a compile time error, saying basically that they don't have the same common reference for hertz and becquerel. because they are of different kinds. And it's not only about Hertz and Becquerel, because you may say this is some strange example. No one uses Hertz and Becquerel in the same field, in the same project. But this is what compiles on every project that I checked, including, well, maybe not Java, but in Paint, in C++, and other languages as well. Gray and Sievert, those are totally different things. They should not be mixed. And this is exactly the same field. This is chemistry. Right? Actually, this is so bad problem and so big problem that one of the libraries, like Aurora Units library, actually does not specify one of those. I don't remember which one, but say we don't provide this because we are afraid of those errors. So they do not provide all of the SI units because of that. And this also works on any other library. 1 radian plus 1 bit equals 2 steradians, and this just compiles everywhere. But it's totally wrong, right? So dimension is not enough to describe a quantity, and that's why we have those additional abstractions. In the library we also have those affine space abstractions, but I will skip exact discussion about it. You can find more on my project, on my documentation if you are interested in this one. Basically it says that we have quantity points and it works perfectly with temperatures, for example. And it also provides additional safety to our libraries. So to summarize, MPUs is about safety, automated by safe unit conversions, preventing of truncation of data. Explicit, as you've seen, is not explicit enough. So explicit constructor is not explicit enough. We have to specify always a unit during construction of a quantity, or provide a point origin for quantity point. Safe quantity numerical value getters always specify a unit, quantity of the same dimension but different kinds, various quantities of the same kind, and affine space abstractions. This is all about safety, about making our programs better, safer, so we can scope on the logic and have fun with Columbus rather than looking into the code and trying to reason out if there are no errors in computations. And there are much more features, not safety related, in the library that are making this library quite great, like composable units, NTTP usage, expression templates to improve readability. You've seen the compiled error messages. Types are quite short and easy to understand if you have some experience with the library, and plenty of other good stuff. There was a question already on the way, but maybe there are more. So that's it for me.